Okay, so again, trying to figure this out. Hopefully you can follow along in the slides. Again, if you have questions, let me know. What you should do is you should just treat this like we do when we have it in class. Make sure that it wouldn't be a bad idea for you to take notes as you go through this and just watching it. Okay, treat it as though it's part of the class. So I don't know how difficult that is to do, okay? But may want to do is just go through each one of these videos, scribble down what you think the key components are, and then basically set up your notes. That's why I'm sort of breaking them into these shorter videos. Okay. When I'm all done, what I'll do is, I really don't think I'll do a complete study since this is all laid out for you. Is that when I get done with this next section, what I'll do is I'll do a review of carboxylic acid and polarity so that you have them available to you. And then I'll figure out what to do in terms of maybe giving you out an outline of key things to know from all of this. Okay, so let's just move on. Okay, finally, there's that we have these lipids that our body is producing and taking in, fatty acids, etc. When we eat some fat or oil, and it's important to get to the cells. The problem is that when you eat fat, which is nonpolar, and it gets into your blood, it's gonna form blobs of nonpolar, like oil and water. Okay, and it's not gonna move anywhere. Okay, so what has to happen? So lipids must be transported through the body so they can be used for energy and make steroids, but they are nonpolar and not normally dissolved in body fluids. To solve this problem, okay, what they are is they can be combined with lipoproteins so they can be transported through the body. And so lipoproteins are like taxis. Okay. For instance, what would happen if they weren't there? Okay. So if lipoproteins didn't carry triglycerides, weren't available to take triglycerides, the triglycerides would all get clogged up, and then you could not get anything through your blood. And so what you want to do is you want to have a clean, clear vessel so that things can move around in your blood. So you do not want to have high levels of fat lipids moving around in your body. So you have to have a way to do that. The way to do that are through lipoproteins. And there are going to be a couple of types of lipoproteins. But before we get into that, let me show you how they work. Okay, so you're going to see a common theme with these, with the same phospholipids and soap, etc. Okay, so this is the blood, which is mostly water. Okay, and what you want to do is you want to move these lipids. You want to move them through the blood, but if you just let them move, what they'll do is they'll just get clobber up, just clump up, and then clog up your blood. Here, where's lipoproteins come along. Okay, so a lipoprotein is kind of like soap. It has, we can kind of draw it like this. Okay. It has a polar outside. And it has nonpolar like cavity. Okay, and what they do, what it does, is it'll grab a hold of the lipids and hide it from the water. And therefore, all the water sees, just like soap, okay, the micelle of soap carries away oil and hides the oil from the water. These guys essentially do the same thing. They hide the lipids from the watery blood, and the water doesn't see the lipids. Okay, so it's like Trojan horse, or whatever way you want to explain it. It's maybe like carrying illegal immigrants across the border. Is they're stuck inside this truck here, and they get through. It's because they're hidden really well. So that's what lipoproteins do. Is they hide the lipids from the blood, and they carry them, and then they drop them off to wherever they need to go, and then they go and get some more. Okay, so there's essentially going to be 3 types of lipoproteins. This is the first type. I put these 2 into one category: chylomicrons and very low density lipoproteins, VLDLs. And what they do is they move triglycerides, cholesterols, and other things to cells so that the cells can use lipids for energy and storage. Okay, so when I showed the slide earlier, how lipids, when lipids move around in your blood, they may go to your cell for energy. This is how they get there, through these 2 types of lipoproteins. Okay, another type of lipoprotein is called low-density lipoprotein, LDL. And what it does specifically is it carries cholesterol to tissues to make steroids, to make myelin sheath, to make vitamin D, etc. So it's very specific. It carries it to cells where it needs to use cholesterol to make things. The third type are called high-density lipoproteins. And what they do is that sometimes there's these lipids that get left inside the blood that maybe not picked up efficiently and are hanging around in the blood and essentially could end up clogging up the blood. So what happens to them is that these proteins here, the HDLs, what they do is they go around and they collect excess lipids that are floating around in the blood. So they're like garbage trucks. They go around, look for any extra garbage lying around. They take it to the liver, and the liver breaks it down into bile, and then it gets transported to your gallbladder, and then broken down further, etc. Okay, so that's it. So those are the 3 types: the chylomicron, and VLDLs to move lipids to make energy and store energy, LDLs to carry cholesterol for cholesterol to make things, and then HDL to clean up. All right, finally, most people here, when they hear cholesterol, probably think a negative thing of it. What happens is if measuring cholesterol is a way of measuring how clogged your arteries are. And the way that they do that is they measure two of the lipoproteins, LDLs and HDLs. Now, LDLs and HDLs are lipoproteins, and both are needed for bodily function. Neither one is bad, they're both good. But we will use them as a diagnosis to tell how our body is disposing of cholesterol. If there's too much cholesterol in our body, then in our bloodstream, that might cause clogging, which causes to have a heart attack. Okay. All right, so LDL, sometimes are called bad cholesterol. This is because if the cells they are taking it are backed up with cholesterol, the LDL can't do its job well enough. Okay, so what we do is we look, so if there's high levels of LDLs, that means the LDLs aren't doing their job. And there's high levels, and that means you have too much cholesterol in your body. Okay, what determines the amount of LDL in your blood? Diet and genetics. Unfortunately, LDLs, I told you, have a job. They do carry cholesterol to cells. But we use levels of LDL in blood work to determine if your blood has too much cholesterol. If there's high levels of LDL, they suggest you have high levels of cholesterol. So that's why they call it bad cholesterol, even though it's not bad. It's its way of measuring the cholesterol. Okay, HDL, high levels of HDL are considered good, because so if you get a cholesterol profile, you get total cholesterol, LDLs and HDLs. High levels of HDLs are considered good because that means they're cleaning out your blood. And again, ways of genetics, diet, and exercise can increase your HDL levels. Okay, so you don't have to know these numbers. Just write them down on the test. But typically, if you get your blood levels done, measuring cholesterol, these are sort of the things that they look for to tell you if you have high levels or levels you should be concerned with. And that's it for lipids.